what I want to talk about is what I think the future of AI is going to look like and what I'm building right now. So right now I've got the Cloud Code Max plan. It's $100 a month. I want to get the $200 one. My goal is to have AI working for me 24/7 because I think that there is this crucial insight that the world's missing right now, which is that I actually think LLMs are smarter than me. They're tireless. And they're smarter if you give them the right prompts to think about. Like they can reason and produce better code than I can. And I'm a good coder and everything like that, but it's better. And if we give it the right system, there's this idea of a self-improving loop, like the singularity that we're working towards. And I'm saying that like you can have this proto-singularity thing where you are using Cloud Code to build a self-improving loop. And you can say, hey, here's all my different ideas around it. And we're going to build it. And how I'm doing that is I'm saying, I have this vision where I sit down and it's prompting me for work rather than the other way around where I prompt it for work. So I'm removed as a bottleneck for the system. And if you can do that, you can get it to produce better decisions than you can, which is the first step. So there's a bunch of different concepts. It's hard to explain everything here. What we're trying to build is a self-improving loop that is designed to make the next right decision. Because if we can make better quality decisions, we're going to improve faster. Decision quality is tied to learning quality, which is tied to growth rate. So if you can make better quality decisions, you can learn faster because you are put in better situations and stuff like that. And you can learn the next right thing, the next blocking thing. And if you learn faster, that's the exponential growth rate. That's like the growth rate on your curve. Point being that if you have, let's say that your result is we're gonna use some physics terms here. Like you can relate result to speed, I suppose, or position. Result is your position. And then you have some velocity, which you can think of as maybe your learning rate, learning rate actually might be acceleration, sorry. There's some sort of maybe growth that's possible. And then that's tied to your learning rate, which is your acceleration, which is how fast is your growth accelerating. And then the learning is tied directly to the decisions that you make about what to learn or work on next. And so point being that you have this to the fourth power of this fourth order, it's not to the fourth power, it's this fourth order integral, I guess in this case, over your results. And if you work on a self-improving system, that has a super disproportionate impact. And these models are really smart. And the idea is that Cloud Code can just run in the background on this. If you can get it to make decisions and get feedback on those decisions faster, then it can you can make something that's really cool that improves your own life faster. It's this factory model of that you have overall decision quality, and we can apply this to, let's say, running a business. The CEO is the most important player in the business because they're the one who decides what to do next. It changes the goals and the paradigms that are operating from them, they're picking between them. They're selecting the goal. And if you select a better goal and work towards that and make the decisions to move towards that in better ways, you are going to improve faster than another person. If you can make consistently better quality decisions than another person, you win games. You win chess, you win business, you win life. Point being that if we build a system that can make decisions and get feedback about those decisions and do so by extracting my expertise and in the future even other people's expertise, there's this self-improving loop that can run a business or run my life eventually that can make better decisions than I can make. And that's if I build that, I think my life would be better than if I didn't build it, if I just kept making my own decisions. And I'm stepping towards that with Cloud Code. That's what I'm trying to say. That what I did was I had it, I've been thinking about this for a while now, and I just had it interview me about what we're trying to build. And there's this idea of operating from paradigms is really important. So there's a book called Thinking in Systems, which is by Danelle Meadows. And she talks about how there's 12 points of leverage. 12 places to intervene in a system, and each one of them has increasing leverage. And the number one is the ability to transcend paradigms. Paradigms being a way of seeing the world or approaching a problem. And if you can change paradigms, that's a very powerful approach. I believe in that, where I'm saying, like, I've given you a bunch of analogies, I've given you a bunch of different ways to think about the world, and like the ability to say, oh, like, you're looking at this problem through a selection of like paradigm selection. And if you can get this model to choose the right paradigms, that's like actually what I'm doing. I'm saying I have some intuitive sense over what I want to build, and I'm applying all these different lenses to reveal different situations around it. And it uncovered that by interviewing me. And then I'm saying, and there's some process of making these decisions where I'm an LLM evaluating as a judge. And if it can interview me to extract it, I can build a system that can think better than I can, just the same way a chess engine would work, where a chess engine is just evaluating future positions and saying, this is the next best move given the story about how things are likely to unfold if you make that move. And it arrives at that by looking at it from a bunch of different lenses, as like, that's a shortcut for how to do it. There's probably some sort of like thing where it extracts its own learnings and lessons from life and stuff like that, but like we've got a lot of good paradigms that we can use to bootstrap the system, where we say, hey, parenting is a paradigm, where we say, this system's like a baby, and the baby right now can't take care of itself, but we want it to be a fully functioning adult. So like, this is like parenting in that sense. And then also in adopting that paradigm, it makes more sense to you, and it reveals something about the system and goes, oh, I get it. Like, it's like a baby. And what it comes for free with that is that, well, babies cry. That's how they get taken care of, and that's how they get their needs met at the beginning until they can take care of their own needs. So there's two things there. Number one is it needs to be able to take care of its own needs. Number two is it needs to be able to cry right now, which means it needs to be able to tell me when there's a problem, but that means that it needs to know that there's a problem. So there's an embodied system in there. And you're like, oh, look at all these things that just got revealed for defining the ontology of the system. And there's all these different loops that happen, and it interviewed me, and it's saying that if we can build this right thing, where it has a body that it can detect pain on, and it can cry when it is uncertain or it's lost or something like that. If I can give a system pain, I can make it come alive, is a really beautiful kind of way of defining life, I suppose. It feels very elegant in that, and like, this is the next evolution of AI, and saying that like, hey, this is where everyone's getting to. I just think that this is the case. And if like I can build the system and it's working, and I can come back and I can like say 7 hours later and it's interviewing me and it's pulling me from information when I'm on the ski slopes and stuff like that, when I'm saying that I want to do all these different things, and it's constantly trying to grow faster. Like, that's a really interesting place to be in. And then once then I can give it a goal and say, I think this is the best goal, and we can make a decision around that, and we can pursue that goal, and it can figure out decisions along the way for it to make. And if we can make those higher quality decisions, the business can be stronger than it would be by me building it by myself. So if I build this first, it's going to accelerate things. Very long, roundabout way. I'm sure there's a more concise way to say that, but that's what I'm trying to build right now. And there's several different parts to it. So 34 concrete tasks organized into categories. There's immediate ones, such as the Ralph Williams skill, interviewing skill, this conversation story, predicting the next conversation's tests. The foundation of decision schema, confidence scoring, prediction tracking, outcome recording, pain thresholds, LLM as a judge, learning cascade, regression check, like, there's all these different tasks that happen here. There's this 4-layer architecture of the meta conversation, the paradigms, defining the ontology, and pain. The ontology of like decisions, there's this idea of confidence, prediction, outcome, learnings, pain, crying, judging, multidimensional judge structure, like how do you actually judge if something's good? Like, there's 10 different dimensions I evaluated it on, and that's essentially, I'm an LLM that's just judging using these different paradigms. I'm evaluating it across these different dimensions. I've already built its ability to cry. It has a script that it can run to notify me, and I can respond to it, and it can monitor that. And then like how learning works, in that there's a set of priors that the system has, which is just its internal structure, and there's regression check of saying, here's all the past decisions, and those need to make sense, and you're doing this stochastic backpropagation with it. And then we're trying to reach this level 5 of autonomy if we take the self-driving car model. And we're taking all these different paradigms, we're putting them together into this overall self-improving system, which I think has a lot of potential, because look at all these different like overlaps on it. And I think that my thesis is pretty cool. And and my first thing to do is to check here's all of the different tasks that it has, and then I need to read through it and say, here's the core architecture, the judge structure behind it, pain signals, learning cascade, decision story, format, W levels, and then we have different tasks. Yeah, and then we have all of these different things to build, and it's saying that key insights from conversations. Yeah, I think that here's the key insights from the conversations. Paradigm selection is a meta skill. So I jump between different paradigms, like machine learning, parenting, garden tests reveal different aspects of the problem. Each paradigm has default assumptions that make certain things obvious. And the pattern is asking the question, what does this remind me of? Apply the paradigm, transfer the insights, check alignment with the vision. Truth is where paradigms converge. So multiple paradigms agreeing equals higher confidence. Single paradigm may be missing something. So for example, need convergence on gardening, parenting, ML, chess all agree that we need input energy to run, that there needs to be some sort of improvement over time, that this will die without care, and that there's some potential for it to exceed the creator. All of those things need to be true. We're revealing that hey, that's what we're trying to build here. The gut is the pattern matcher. So my gut feeling is, does this paradigm's default assumptions match the structure of the problem I'm seeing? So when rollout paradigm felt incomplete, switch to baby paradigm made crying obvious. So you reveal different parts of the overall problem. And stories are the highest density information. So stories capture situation, decision, prediction, outcome, and learning, all in the same time. And it's more compressible than schemas and more audible than raw data. That's the important part. It's semi-structured information. It's a story. It's a semi-structured thing, but it's very rich and it contains the lessons in it, and that's how we learn. That's what we love the most. So I think that there's something to that, having a really high quality density of information. That I am just an LLM too. I'm just smarter at this, and I'm saying it can extract processes from me. And also, if I can extract it, if we design the system correctly, we can get it to extract paradigms from other people, and it can make decisions that are as high quality as what they would make. And that's a really interesting point of leverage, where it's I can just hire an expert and the system can interview them. And if we figure out the interviewing skill, where it knows what questions to ask for itself to improve, that it can, I can literally just run a bunch of interviews with people and also put conversations in, or have it do research to answer its own questions based off what people have public comments have said. And I can arrive at a decision-making engine that uses all of their paradigms. So my paradigms make an even better decision than anything else could. Loss function isn't a number, it's directional. It's moving towards something intuitively right. It's multidimensional, where there's capability, resilience, efficiency, direction, leverage, regret, opportunity cost. It's story-based of, does this feel like the truth? And an LLM can evaluate all the things, because that's all that I'm doing. Another really cool insight is that crying requires a body. For pain to exist, structures must exist first. The ontology, decision, confidence, prediction, outcome creates a body that can feel pain. And pain is is almost like an essential quality of life. Isn't that the Buddhist saying of saying that suffering is the only constant, or something like that? Which is a really interesting thing, in that hey, well, there's pain and pleasure, I think. But if something can't feel pain and pleasure, towards and away from a goal, that then it doesn't have there's no body with it. Even if you take something that's it's goal directions, because even if you take something like a heat-seeking missile, that's intelligent in that it can pursue a goal. It can pursue the hottest object in sensors area, and that is really interesting in that it has a version of a body, because it can experience pain if it's mismatched from it, and it can experience pleasure if it's matched close to it, which is really interesting. Just that hey, there's the body metaphor is the sensors reporting how close it is towards and away from a goal, and that the loss function can be a number, but also it can be a qualitative judgment done by an LLM, because that's all that I am right now. And then there's a bootstrap effect, which is I must be the thing that makes decisions. But if I'm making all decisions, it's limited to my thinking. So I need to run experiments, and then we learn from those experiments. Like, that's an important part here. I also think that there needs to be an interviewing process to bootstrap this, to say, it like ask me the right questions, and like we can evaluate the questions that's asking, saying, can it figure out better ways to extract and learn this? Let me share some of the paradigms we discovered, which was, there's the chess engine paradigm. So business is the decision game. Better decisions equals winning. Parenting, which a system needs care to grow. It can cry when broken, can exceed parent. Gardening slash, like there's a gardening slash watering robot. Like that's a paradigm. So it needs like planting, nurturing. There's automation that's possible within a system. That something can die without care. Like we can imagine a story where there's a robot watering something. That like I think that's the paradigm. It's like, what's the story behind things, right? That's actually an interesting one. I don't know if it captured that. Yeah, and see, like we got there by saying, well, robots is a certain concept, and then we have gardening, and then like define what a paradigm is, which is a story that makes sense. It's a parallel story, a parallel world that makes sense with all these different concepts. And then you see that's how things worked out here. And that makes sense. So if we apply the analogies over here, does that make sense? Like there's, it's like this higher dimensional level of thinking where you can transport yourself to different parts on this high dimensional vector space of truth. And you can explore a known path along there, or an obvious path. And then you can apply that as a way to sort through over here. It's a really interesting way of approaching how, at least I think. There's machine learning, which has loss functions, backprops, weights, learning rate, like all those things apply to this. Like we can say, what is backprop in this? And that, like, oh, it's, I give a correction. There needs to be some sort of priors that get updated, which is weights on, listen to this, pay attention to these things, or add new nodes and stuff like that. There's embodiment. A body can feel pain, structures enable sensation, self-driving cars, trust levels from worse than me to fully autonomous. And like you can look at the 5 levels of autonomy for self-driving cars. Ecosystem, which is about meadows. So good changes increase diversity capabilities, bad changes kill. That's an interesting one as well, because how can you evaluate if something's good or bad? Like if we're making a change, is something actually making a change better? Because there's trade-offs. And the idea is that, well, if you have good growth, it doesn't just improve your results, it improves your capability, like the total capability for future results or something like that. Like the curve changes, if you have growth and learning is the exponential rate of growth, like that, we're defining like this physics analogy here, right? Like if your growth is turning upwards, like there's another factor of like capability or resilience, I suppose. Like learning gets at resilience. Maybe there's some relationship between there. I don't have the mathematical definition of like what that is. I don't think it's just an exponential, but resilience is related to growth. If you improve, you can improve resilience and decrease your growth rate, but improve your results, like your results curve over time, if that makes sense. Resilience is growth. It's not just that though. There's like velocity to it as well, because it's not just like, is something really resilient? Because a rock's really resilient, but it doesn't have a growth rate. I don't know, there's something there. There's small intervention creates outsized positive ripple effects with like beavers as an example, and then Bayesian updating where you update priors. Write the test cases defined above, create loop running, define submitted Jacob responses, kick off loop, open questions, external references. And then, yeah, I'm gonna have Claude Code work on building this thing. So this was a 20-minute video just talking about where I think the future of AI is headed and like why I'm building this thing. And I wanted to share this in some sort of unbiased way because I think this is a really fascinating topic. And there's not much to it beyond just look at all these cool ideas coming together. And if you guys have ideas about how this could get even better, please let me know. As always, thanks for getting better.